Hello and welcome to the mean value theorem part of our course. Here's some extra problems about the mean value theorem and if it applies and how to find values guaranteed by it. So it says for the following, determine if the mean value theorem applies. If not, explain why it doesn't. If it does apply, determine the value C that the mean value theorem guarantees. So when you look at the first one, trying to figure out if the mean value theorem applies here. First, you have to check that it's continuous on the interval 0 to 5. If you can see, this is the ninth root right here. So you can take the ninth root of anything because it's an odd root, plus 2. So this function is continuous throughout its domain. And so it did pass a continuity test. Now we have to determine, though, is it differentiable? Because it's not necessarily differentiable just because it's continuous. So to figure out if it's differentiable, we're going to take the derivative. And it's a pretty straightforward chain rule. Thank goodness. It's 8/9 x minus 3 to the negative 1/9 plus 0. So the derivative is 8 over 9 times x minus 3 to the positive 1/9. Now, we're trying to figure out if it's differentiable. It's only differentiable if the derivative exists. Now, see the derivative? Just focus on what type of equation it is. Is there any values of x that would make this equation undefined? And that's pretty easy to do because we know you can't divide by 0. And it's very obvious that if you plug 3 into the bottom, 3 minus 3 is 0, it will make the whole bottom 0. Therefore, this fraction does not exist at 3. It's undefined at 3. Therefore, the derivative, which is what this fraction is not defined at 3. So this function is not differentiable at x equals 3 because you can tell by the derivative. Now, the mean value theorem still could apply if it's not differentiable because it may not be an interval. But if you look at the interval, since 3 is in the interval, this function is not differentiable in the interval. Therefore, the mean value theorem does not apply. So it does not apply, because f is, even though it's continuous, it's not differentiable on the open interval 0, 5. So it wouldn't really matter if it wasn't differentiable on the ends, but you won't see that all that too often. So that's that one. Doesn't apply, it's not differentiable. So the next one. Oh wait, I want to show you this. See this function? This won't take long because I already did it. See this function? Let's look at the graph quickly right here. So here, ignore that one. That's the top function is what we're looking at. You see at 3 right here, there's a corner. So graphically, we know that also means not differentiable. So it's not too surprising that we determined that it wasn't differentiable at 3 because the graph has a corner. So back to the next problem. Same question for this. First of all, it's a cube root question. So this is continuous. You can take the cube root of any value of x. So that's no problem. We need to figure out if it's differentiable now, just like the last problem. So the derivative, this is also a pretty straightforward chain rule. It's very similar. 4/3 x plus 2 to the 1/3 plus 0. So we're done. You can still take the cube root of anything. You're not going to have a division by 0 here. So since you can plug any value of x into the derivative, and it makes sense. You don't get any undefines. This is differentiable on this entire, actually this is differentiable everywhere. There's no value of x that makes this non-differentiable, and we already said it's continuous everywhere. So yes, the mean value theorem applies. So now we're going to find the value of c that is guaranteed by the theorem. There has to be at least one in this interval. So the mean value theorem says the derivative at c, or it's saying there must be some point whose slope is equal to the average slope, which is y2 think of this as x1, x2. You can do it that way. y2 minus y1 over x2 minus x1. If you like the formula, it's f of b minus f of a over b minus a. So we have to find this value of c that's true for here. So f prime of c is, we already did f prime, so f prime of c is 4/3 c plus 2 to the 1/3. We have to solve for that. C equals f of 6. You plug 6 into the function. 6 plus 2 is 8. 8 to the 4/3 means the cube root of 8, which is 2, to the 4th, which is 16, plus 3 is 19. So it was really just the cube root of 8, 2, to the 4th, 16, plus 3 is 19, minus f of negative 1. When you plug negative 1 in here, it's going to be 1 to the 4/3, which is 1, plus 3 is 4, over 6 plus 1, which is 7. And now we just have to solve this. I think, well, it'll be easy. Watch. (19 minus 4 is 15). Now here, I think it's a fraction equals a fraction. So I think most students like to cross multiply here, which is completely fine. So that's what I'm going to do. You can multiply both sides by 21 to get rid of the fractions, but I'm going to go on and cross multiply because that's going to take care of the fractions too. So I'm going to have 7 times this is 28. And then 3 times 15 is 45. So we have c plus 2 to the 1/3. I'm solving for c, remember, so I'm trying to get everything away from it. So I'm going to divide both sides by 28. 45 over 28. Okay, and then I'm going to probably use my calculator here because now things are going to start getting ridiculous. To get rid of this 1/3, you're going to raise both sides to the 3rd power. So I have c plus 2 equals 45 over 28 to the 3rd, which is I was going to change it back to fraction. It's not letting me, so I'm going to say 4.1511. If you want to keep the fraction, just cube the 45 and cube the 28, but this is good enough for this problem. Subtract 2. And that's the value of c, where the slope of the tangent line is equal to the slope from x equals -1 to x equals 3. So that's that. Remember, this has to be within this interval. So I kind of there's no great check I can think of right now, but at least you know that this has to be between -1 and 6 because that's what the theorem guarantees. So if you look at the graph we just did, this one, that's what the graph looks like. And we were basically going from -1, which is right here, to 6, to 6, which is all the way over here. But the key thing here is it doesn't matter. This point right here is not a corner. So the mean value theorem would apply everywhere. So those are two good questions. Please ask next time we meet if you have any questions.